All right, so I want to do a couple example problems using critical point thoughts with some functions. So we're going to find the absolute max and min on an interval. We're going to note the critical points, or critical numbers, okay? And remember, critical numbers or critical points occur when f prime of c is equal to 0 or is undefined. And to do this problem, we got to remember that we're using the extreme value theorem. And the first thing I want to do with the red function here, which is, by the way, number 50 out of the textbook in 4.1 for Stewart version 5, is that since it's a continuous function, right, a polynomial on a closed interval, we know there's an absolute max and min in this interval. So we know there's a global max and min because of EBT. All right, so we're going to move these facts down, and then we'll do another problem here after that, okay? I'll group all that, and we'll come back to this, all right? So move that aside. All right, so everyone, don't multiply this out ever. This is why we learned the chain rule. Okay, don't ever multiply this out. So two things. One, since I know EBT, I don't think about this on the interval. I literally plug in the endpoints immediately and get the values. I put -1 in here, and I get -1. 1 minus 1, I get 0. I plug in 2 in there, and I get 27. I don't know if those are absolute max or mins, but I know they might be, so I get those values. The next thing I know is that since this is a continuous function, I'm very interested in the critical numbers that are inside the interval. To get those critical numbers, I have to take the derivative. Everybody, this is a chain rule. Bring the power down. Leave it alone, right? Take the derivative of the inside. All right? Everybody, this is why factoring is so important for us, all right? Because we should see that it's this. That x squared minus 1 is x plus 1 times x minus 1. If I set the derivative here, f prime of c to 0, and it's a continuous function, so there are no undefined points because it's a polynomial, right? The derivative here was a polynomial. Does everybody agree? So no undefined points. This is why knowing what type of function helps. C would be 0 at -1, 1, and 0. Everybody, -1, 1, 0. Guys, all three of those critical numbers are inside the domain. It happens that -1 was one of the endpoints. Does everybody agree? That's still a critical number. So we just noted the critical numbers right here. And these would be our, what I call CPs in my classroom. Last thing I'm going to do to figure out global max or mins is I'm just going to take the values of these three. I've already done -1. So I'm just going to do f of 1. I plug 1 in and I get 0. I plug 1 in up here and got 0. Back to the original function. I'm looking for values. And I would plug in f of 0. And I get -1 is -1. I am now looking at the 4 black points that I did in the same color on purpose. And I'm deciding what is the global max and the global min. What is the absolute max and the absolute min? Different terms. I'm just looking at values. I think the biggest number there is 27. That is the global max. I'll call it the absolute max. This is the absolute max. Boom. I think the absolute min this time is -1. Everybody, we got to be real careful with our English here, okay? And what I mean by that is I didn't ask where they happened. I asked what they were. So let's be clear. Find the absolute max, 27. Find the absolute min, -1. Where does the absolute max happen? At x equals 2. Where does the absolute min happen? At f equals 0. Everyone, you catch that the max happened at an endpoint, but the min happened at a critical number. Everybody follow? And we have just done this function. This problem. Now, we can use this information very soon to graph this. This is going to help us graph a lot of stuff. All right? Nice function, pretty clean. All right, so let's box all this up and get it out of town. All right. There we go. Doing the same thing, rinse and repeat time, but a different function. This is this one is problem number 52 from the book. Again, Stewart, version 5. All right. It is a rational function on the closed interval, -4 to 4. Again, we're looking for absolute max, absolute min. All right. Again, we're going to note the CPs. The first thing I want to do with this one, and I want to think about domain. Is the domain continuous between -4 and 4 for this function? Can the bottom ever be 0? I hope in your heads, everybody, you can picture this graph for the bottom. X squared plus 4 is a parabola shifted up 4. Is the output of the blue parabola ever 0? No. So can the bottom ever be 0? No. So again, this is why we think about mother functions so often. So I can say immediately that the domain, that this function is continuous in the interval, right? In fact, it's continuous everywhere. If you didn't have an interview, it'd be all real. So we know then two things. We know that EVT tells us there will be a max and min. Does everybody agree? Because it is continuous on that closed interval. Boom. We know there's a global max. We know there's a global min, or an absolute max, absolute min. Again, it's just a different way of saying the same thing. The other thing we know is a critical point will occur. So we're going to have to take the derivative first. And I'll leave that blue there. In black, f prime of x. Icky. You ready for this? Here we go. What's the derivative of the top? F prime, right? I think the derivative of the top is just 2x times the bottom minus the derivative of the bottom, 2x times the top. Okay. Over the bottom squared. All right, I do want to clean this up before I solve it for 0. Oh, what should I have done first? I skipped one step. I should have put -4 and 4 in right away. Right, my endpoints? I forgot that. Hopefully I would have caught it when I did the critical points in between. I missed it. All right, guys. I love this because everybody, you all see this as an even function? You should. You should have noticed this function, f of x, is even. So I only have to do one of these two. All right, it's 0 for both. I plug it in, it's 0. No, it's not. No. What am I doing? I'm doing it too fast. I got to square 4, don't I? It's 16 minus 4 is 12 over 12 20ths? 12 20ths. 12 20ths. Take away. Tell you what, I'll reduce it. Here's what I'm going to do. I'm going to reduce that or simplify that if it's the answer. Yeah, it's yeah, you're right. 3/5. I suppose now thanks a lot. I'm going to have to fix it. Can't live with it. I'm a perfectionist. You guys, that's true. I'm not a perfectionist. All right, everybody. I don't know if those are maxes. I don't know if that's a global max or a global min. 3/5. It could happen at 2 spots. We'll get there next. Everybody, now I'm going to finish finding the critical numbers. I know it's defined everywhere in the interval, so I'm going to, well, here's what I'm going to do. And again, this is a big time move. I'm going to factor out the 2x. I recognize for most of you guys, you would distribute the 2x and look for like terms. I know a lot of you would do this, all right? And we're going to come to the same answer. But when I can see a common factor here, I'm going to tend to factor first. I saw 2x, I yank it out. X squared minus x squared. I see that it's 8 inside, right? 4 plus 4. 8 times 2x. I think the answer here is this thing simplifies to this. Yeah, so listen, we're going to set this whole thing equal to 0. And I'm going to say f prime of c equals 0 at 0. Is 0, again, we agreed at the very beginning that this was critical, that it was a continuous function between -4 and 4. So I'm going to go way back to the top. And I'll do it in green next to these red ones, a little December color. f of 0 is, well, I'm pretty sure f of 0 is -1. Oh, this is I like this problem. So what is it? We'll start with the minimum. What is the global minimum? -1. It happens at 0. What is the global max? 3/5. Where does it happen? -4 and 4. Boom. And I could label those, but we just said. And everybody, the critical number for this function, actually for not just the interval, but everywhere, is simply 0. We can start to use this information to really make graphs look pretty. This is a really cool graph, guys. All right, we're going to get there to graphing them shortly. Keep practicing.